Okay, we're going to be looking at the homework for 2.6, which is looking at limits to infinity. Ooh, limits to infinity and horizontal and vertical and oblique asymptotes. So let's look at that. All right, so let's start it off. Let's look at number 1. It's putting it on a different screen. There it is. Okay, so let's look at this one. So it says use the following parts of the function to evaluate the following limits. Okay, so we're just looking at the picture and trying to figure out what happens. So looking at this one, let's make it just a little bigger. It wants to know about the limit as x approaches 6. So you can see 6 is right here. And it's just going to, what is that, -2? So there's nothing really weird going on there. All right, now how about as we approach -1, and we're doing it from the left. So see, this will be the left of -1. So we want to come in from the left there. So as we come in from the left, we're coming up and we kind of stop at this point here, and that point happens to be at 5. So, oh, sorry, we're coming in from the right. Okay, so let's see what happens when we come in from the right. So as you come in from the right, you're going to, I know it's an open circle, which means that it's not actually defined there, but we're looking at a limit. So what happens was when you come into -1 from the right, you're going to notice that's the axis. So you're going to 0 there. All right, now -1 from the left. So as I come in from the left, like I said, you're going up here to this point, which happens to be a 5. All right. Now it says, what can you tell me about the limit in general at -1? So remember, they have to agree when you're coming in from both sides. So you're coming in from the left and you're going up here. You're coming in from the right and you're going kind of down here. They don't agree with each other. So in general, the limit does not exist. Have to agree with each other. There's more. All right. How about 4 from the right? So here's the 4 right there. You see that? So let's come into 4 from the right-hand side, and we're going here, which is -2. All right, now let's come into 4 from the left. So from the left side of the graph, notice to the left of 4, you're actually on this part of the function. You see that? So this is going up, 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 up. And it's just going to keep going up and up and up. So it's actually going to infinity. I'm going to put infinity. Let's see if it'll take that. Yeah. All right. So it's going to infinity. It's going up, up, up. So in general, does the limit exist? No, they don't agree with each other. Again, this one's going way up this way. This one's kind of stopping. They don't agree in general, so it doesn't exist. Has to exist from the left and the right, and they have to agree with each other. So now we're looking at what happens as x goes to infinity. So we want to know what happens when x is just getting really big. So you see, here's the x-axis. We want to follow the x-axis to infinity, all the way over that way. So let's just see what's happening to this thing. I just wanted to write on the screen here. So here is where x is going to infinity. So if we kind of follow the graph there, it comes down and it looks like, I mean, it's just kind of chilling right there. It doesn't look like it has momentum to keep going up. It looks like it's just going to kind of coast there on that line. What is that line? This is the horizontal line at 0, right? So y equals 0. Essentially what we have there is an asymptote. So you could not kind of, but see, you can think of that as that dotted line kind of coming out. So we've got an asymptote there, but it's going to 0. Now, how about negative infinity? So look at it as it goes the other way. And again, just kind of imagine following it out. And it just, I mean, it seems like it's just kind of chilling on that line there. And this line happens to be the horizontal line at 1. So the equation for the asymptote is y equals 1, which means the limit itself is just 1. Finally, all right. Looking at number 2, it says find the limit of the function as x approaches infinity and as x approaches negative infinity. So we want to know what's happening when x gets really, really big. So if you recall, the limit rules work for limits to infinity as well. So what we can do is we can actually break this up. And look at it as 2 separate limits. So then we have a theorem that says that the limit for 1 over x, so 1 over x looks like this. So as x goes to infinity, this thing goes to 0. You see it? It's going to 0. As you go to negative infinity, it's also going to 0. And because this is 24 over x squared, that's really just 24 times 1 over x times 1 over x. So this whole thing here is just going to 0. When your denominator gets really, really big, you go to 0. That's it. So if that part's a 0, this is a constant. That's a pi. So really, we have pi minus 0, which would just be pi. The same thing's going to happen when we go to negative infinity, especially, well, this is squared, so the negative doesn't really matter anyway. But also, it's just a denominator getting really big or really small, either way. But, and by really small, I mean negative 50 million, you know. So really big negative or really big positive in your denominator, and you're going to 0. And so the answer here is just going to be pi. And again, it's going to be the same from either direction. All right, let's look at this one. Same thing. And again, we can use our limit laws. I'll break this one all the way up just for the heck of it. We can use our limit laws here. So we could break this up and say, okay, this is the limit as x approaches infinity of 10 divided by the limit as x approaches infinity of 19 plus the limit as x approaches infinity of 1 over x. And we know that this one is 0. This is a constant, and this is a constant. So what happens when you go to infinity of 10? Well, you're 10. What happens when you go to infinity with 9? It's a 19, right? So these are just horizontal lines. If you look at the graph, this is the horizontal line, y equals 10. As you go to infinity, you're just 10. You're not doing anything. So same with the 19. So this is just 10 over 19. Because of, you know, the limit laws where we are allowed to just break this thing up, and then we know that 1 over x is 0. So this is just 10 over 19. And the same thing's going to happen at negative infinity. This is just 1 over a really negative number, really big negative number. It also just goes to 0. So all right, let's check out this one. So in this one, we can again but we can break this one up again. So we can look at this as the limit as x approaches negative infinity of the cosine of 14x divided by the limit as x approaches negative infinity of 17x. And actually, you know what? I'm going to break it up a different way. I'm going to break it up like this. The limit as x approaches negative infinity, cosine 14x, times the limit as x approaches negative infinity of 1 over 17x. So see, I just took this part of it out. Why did I do that? Because I know that this part goes to 0, right? 1 over 17x would go to 0 because it's 1 over a really big negative number. Again, you can kind of take that 17 off if you want and have a 1/17. But the point is he goes to 0. What does cosine 14x do? Well, cosine is bounded between -1 and 1. He never changes from there. So if you think about it, we would know that -1 over 17x is less than or equal to our function, which is less than or equal to 1 over 17x. You see, we know this thing goes to 0. We know this thing goes to 0. So what does that mean about ours? Well, we must also go to 0, right? We're stuck in between these two. Whenever you have a cosine or sine, you've got this sandwich, right? So cosine stuck between -1 and 1, sine is stuck between -1 and 1. So that cosine 14x is stuck between -1 and 1. Divide them by 17x, you're now stuck between -1 over 17x and +1 over 17x. And again, we know those both go to 0. So that means our guy must also go to 0. So we actually use the sandwich there and there. All right, so let's look at this one. The idea here, there's several different ways to think about this, but essentially what we're trying to find is a horizontal asymptote, right? We're trying to see what happens when x gets super, super big. So we move to the right on the graph and keep on going. So what we're really doing, again, is focusing back on the fact that the limit as x approaches plus or minus infinity of 1 over x is always 0, okay? And so even if you multiplied that by a 20, it's still going to be 0. 20 over x is still 0. So the idea is to get this. That's kind of the first thought here. So what we're going to do is we're actually going to pick the x with the highest exponent. So notice that would be x to the third here. So what I'm going to do is I'm going to come in and I'm going to multiply the top and bottom by 1 over x to the third. Essentially what that does is divides everybody. Let me use the skinnier one. We're going to divide everybody by x to the third. Okay, and then let's simplify this. So this would be -4 minus 2 over x plus 4 over x cubed divided by 7 plus 2 over x minus 4 over x squared. So now tell me what happens to this guy, this guy, this guy, and this guy. So all of those are a number over x, so they all go to 0. So 0, 0, 0, those are my arrows, 0. What are we left with? -4 over 7. So another way to think about this is we're talking infinity here. So the only things that really matter, numerator and denominator, are their leading terms, okay? So this is all that really matters when you think about infinity. Those other things don't matter. This is all that really matters when you think about infinity. Those don't matter. So if you look at -4x cubed over 7x cubed, this is -4/7. Okay, so that's the idea, is that those other terms don't even matter. It's really just about those leading terms. They're going to tell us what's going on. So this one is just going to be -4/7. That's not going to change if you come from the other direction. These would still all go to 0, and you'd still just get, well, actually, hold on. The x is being cubed, so a very large negative number. Well, the negative over the negative would cancel anyway, so never mind. So that's still going to be -4/7. All right. This one is the same kind of deal. You would do that same thing. So essentially, it's all just about the leading terms. So who's got the largest exponent in the top? He does. Who has the largest exponent in the bottom? He does. So if you just look at these two, this would be 4x over 2. I don't know why I didn't simplify that. This would be 2x. So what happens to 2x when you go to infinity? It gets really big, right? It goes to infinity. What happens to 2x if you plug in negative infinity? It goes to negative infinity. So this one is a little bit different. Technically, it doesn't have a limit, but because we are doing limits at infinity, we can actually plug these in. So this essentially comes down to just being a 2x. So if you plug in an infinity, you will get an infinity. And if you plug in a negative infinity, now remember it was 2x. So 2 times a really big negative number is going to end up giving you a negative infinity. All right, so this one we can use the limit law with this 5th power here. Are we even going to need it though? Let's see. So we do have a rule that says that, the power rule that says I can look at this as 1 minus x cubed over x squared plus 6x, and then bring that to the 5th power. So I can kind of do that 5th power at the end. So let's check out this one. And again, remember, it's really all just about the leading terms. The leading term is the term with the highest exponent. So if we think about it, this is really negative x cubed over x squared, which would be just a negative x. So if I'm going to negative infinity, those negatives would cancel. This thing would then go to positive infinity. Now bring it to the 5th power, it's still positive infinity. So this is actually going to be going to positive infinity, okay? So here's my infinity. Yay. All right, let's look at this one. We're going to do this one just the same way we did the others. There's a bunch of roots in here, but roots are just fractional exponents, right? They're still just exponents. So if you want, just go ahead and rewrite this using exponents. So this is 5x to the 1/5 minus 4x to the 1/7 divided by 8x to the 1/5 plus 4x to the 1/7. So who's got the bigger exponent? In the top, that would be this guy, and in the bottom, that would be this guy. 1/5 is bigger than 1/7. So see, these are going to end up going to 0. We don't have to worry about them when we do that division. They don't really matter. So it's really all about 5x to the 1/5 and 8x to the 1/5. So my arrow here, I use arrows and not equal signs. The arrow is saying that this goes to this, okay? And then, of course, this is actually equal to 5/8. So that means we're going to 5/8. Notice the plus and minus didn't matter here. So even if this had been positive infinity, we would have done the same thing. So this is going to 5/8. Yay. All right. Let's see, for this one, this is a limit. Notice it's not a limit to infinity. We've just got a -2. We want to come at it from the left. So the first thing I would do is let's just try to plug in that -2. So if I plugged in the -2, I get 10 over 0. Now, what this tells me, this is actually pretty important. This tells me that there is a vertical asymptote at x equals, what do we just plug in? A -2. That tells me there's a vertical asymptote. So remember your graph. If you have a vertical asymptote, essentially, you're either going to go up as you get close to it, or you're going to go down as you get close to it. So coming in from just one direction, the only possible answers here are either infinity or negative infinity. When we get to this asymptote, we're either going to go up, 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 or we're going to go down, down, down. So we really just have to figure out which one. Do we go up? So are we going to get positive values, or is it going down? Are we going to get negative values? So let's just think about where -2 is. Here's -2. I want to come at it from the left. So if I'm coming in from the left-hand side, we could maybe kind of look at -2.1. That would be just a little to the left. So let's check that out. So I'm just going to plug in a -2.1. Notice now, again, it's not about really the value. We're concerned with whether it's going positive or negative. Notice that top would actually be a positive number because it's two negatives. On the bottom, we'd have -2.1 plus 2. That does not get us out of the negative, right? It leaves us there. That's actually 1/10. So notice if you flip it, it's a 10. So if we had gotten closer, you see how those would keep flipping, and it would just, we'd have 100 if we did 2.01, 1,000 if we did 2.001, et cetera. But notice this is a positive over a negative, which means we must be going to negative infinity, right? A positive divided by a negative would give me a negative. So this is going to negative. So my picture is not right at all in this case. So here's our -2. And it turns out that when we come in from the left, we're actually going down. So we have a vertical asymptote here, and we're actually going to negative infinity. Yay. All right, we'll do one more and then stop this one for now. So this one, we're coming into 0 from both directions. Notice if you plugged the 0 in, you would get 9/0. So that lets us know that, that was a bad stop. Okay, so because we're getting 9/0, we know that we have a vertical asymptote at x equals 0. We just have to figure out whether it's going to be positive or negative. Notice this is a 7th root. So as we come into 0 from the right, let's try, I don't know, you want to try like a 0.1, which we would have 9/8 times the 7th root of 0.1. So the 7th root of that is going to be a very tiny positive number, right? Times 8, still a very tiny positive number. So then when you kind of flip it up, it's going to be enormous. So this is going to positive infinity. Now, as you come in from the left, that would be something like -0.1. Now, if this had been a 6th root, I couldn't do this, but this is an odd root, so I can take the 7th root of that. I would get a very tiny negative number. Times 8, still a very tiny negative. So then when you flip him up, he is going to be a very large negative number. So we'll get negative infinity. So coming in from the positive side, we get positive infinity. That coming in from the other side, we're going to get negative infinity. So that's what this guy is going to look like. So this one will be the positive infinity coming in from the right. And then we'll have a negative infinity coming in from the left. All right, so that was looking at, now this is going to continue with the same, but I've got to get to class. So we'll pick this up in the next video.